Let's look at an example of a microgrid. In this way, you will get insight about the use of a forecasting wind and solar energy for better network control. I will describe a microgrid setup that is located at the Department of Electric Sustainable Energy. You will get a better idea of how a microgrid could look like, and you will see how most of the concepts that you have learned merge together. The name of this microgrid setup is DenLab. DenLab was built as a demonstration lab for the system integration of renewable sources, energy storage, and power electronic devices. In this setup, renewable sources are emulated and control algorithms are implemented and tested. A programmable logic control or PLC is in charge of the automation of the electromechanical processes in the laboratory. A PLC is a digital computer that allows the control of machinery and other devices. In DenLab, the PLC is used to control the power converter devices. You can see how it looked like in the screen. DenLab provides flexibility to emulate different load patterns and generation units. This is done by means of 9 power converters and 2 motor generator sets of 5.5 kilowatt and 30 kilowatt. There are 180 solar panels that can be connected to the test facility or redirected to the grid. The power capacity of the laboratory is 50 kilowatt. The operational behavior and characteristics of the components to be studied in the lab can be programmed at the main computer using a specialized software. The program can be downloaded to the PLC. In DenLab, the control of the microgrid is centralized. In this kind of control, the control commands come from a microgrid central controller. In DenLab, this microgrid central controller is the PLC, and the control algorithms are implemented using the main computer. The PLC sends the set points to 9 power converters that are physically placed at DenLab. In this way, the power supplied or consumed by the converters can be controlled. Also, the output of the motor generator sets can be controlled. In this way, a variety of components can be emulated and the real power flow at DenLab can be monitored. The communication between the PLC and the converters is done using a communication protocol called Profibus. The purple cables in the figure allow this communication. Let's see now how the control is applied to DenLab. In your screen, you will see a diagram of DenLab. As mentioned before, the PLC sends the control commands to the power converters according to the control algorithms that were implemented in the main computer and that are executed by the PLC. The currents that flow to the autonomous grid in DenLab represent the currents that would flow in an analogous physical system. DenLab can work grid connected or off grid. These characteristics is important for a microgrid. In DenLab, a load of 10 households is emulated. The load can be assumed uncontrollable, like in traditional power systems, or controllable in that case that we apply demand-side management techniques, such as demand response. In this setup, the emulation of the wind turbine is done with the help of a power converter and a motor generator set. Wind speed data is obtained from the anemometer placed at the roof of the building. This is the input of the wind turbine model. The wind turbine model calculates the power that would be supplied by a wind turbine for the respective wind speeds. The converter's set point is calculated from the power output of the model. The converter sets are connected to the motor generator sets. As a consequence, a change in the set point of the power converter makes the power generator set to turn slower or faster. In a real system, the motor generator sets would be substituted by wind turbines. By using wind and solar forecasting, the control algorithm defines when to charge or discharge. Autonomous system and islanded system face stability challenges, particularly when most of the generation comes from renewable sources. For this reason, storage devices or backup systems are required. The use of forecasting methods can allow the system to make the best use of the storage devices depending on the weather conditions. If, for example, today is a cloudy day, but it is forecasted that tomorrow will be a sunny day, the optimization algorithm may decide that it is a good idea to make use of the storage unit now because there will be the possibility to charge it tomorrow. Today, you were able to get acquainted with the real setup of a microgrid system. I hope that you enjoyed it. The integration of renewable energy poses challenges at different levels in the power system. In this course, you have been briefly introduced to different relevant concepts. You have learned about the structure of the traditional power system, and you have learned about the main changes that are likely to occur. You have also learned about the need for power converters and the need for control and forecasting. I hope that this course has opened your interest to dive into this topic even further. I hope to see you again in the future.